Hi, so today's lesson is going to be about conversions. So you're going to learn how to convert from one unit to another. So for example, if we're looking at units for mass, like kilograms, grams, pounds, ounces, tons, and other units of measurement for mass, you should be able to convert between units, right? From, let's say, ounces to grams, grams to kilograms, and then kilograms to pounds, and so on and so forth. So that's one of the main things that we're going to look at today, how to convert between units. And not just for mass, but also for volume, for distance or length, and also temperature. So the very last part of this lesson is going to cover conversions between temperature units. So there are three main units of temperature that we use. That's degrees Fahrenheit, degrees Celsius, and Kelvin. So let's go back to the metric system briefly. So last time you learned that the metric system uses prefixes, and that's actually the beauty of using the metric system, because it uses prefixes that allows us to convert between units a lot easier. So for example, you have prefixes like tera, giga, mega, kilo, hecta, deca, all the way to pico. And each of these prefixes has their own symbol. So tera, for example, has the symbol capital T, giga, capital G, mega, capital M, and then you have the kilo, hecta, and so on and so forth. And each of these prefixes contain a numerical value. Okay, so for example, kilo has the numerical value 10 to the third power, and 10 to the third power, as you already know, is equivalent to 1,000. So when you put a prefix in front of one of the main units, like the grams, liters, meters, and seconds, it means you're basically multiplying it by some numerical value. So if you put a kilo in front of the gram, that means that you're multiplying the gram by 10 to the third, or multiplying it by 1,000. And if you put, let's say, mega in front of second, right, megasecond, the symbol mega has a numerical value equivalent to 10 to the sixth power, which is basically a million. So that means that you're multiplying that second by 1 million. And another example would be, let's say, micrometer, right? If you're using the symbol micro, the prefix micro, that means you're multiplying that meter by 10 to the negative 6. All right, so in this slide, you're going to learn two things. I'm going to show you two things. The first one is converting from any prefix, let's say kilo, hecta, deca, centi, milli, micro, and so on and so forth, to the main base unit, and vice versa. So base unit is in grams, liters, meters, seconds. Okay, I'll show you how to convert from kilo, kilometer, let's say, to meters. And the second thing that I want to show you involving the metric system is converting from one prefix to any other prefix, and vice versa. So now it's not just the main unit. Now it's any prefix listed here in the metric system. All right, so let's look at this first one right here, converting from any prefix to the main base unit and vice versa. So I mentioned previously that these numerical values are basically multipliers. So if you put a K in front of a gram, then you're multiplying that gram by its numerical value. Okay, so they're basically multipliers. So let's say convert 1 kilometer to meters. Right, and so a kilo is equivalent to 10 to the third power. And so if you put a kilo in front of a meter, that means you're multiplying that meter with 1,000, or 10 to the third power. And so if you substitute that number for the prefix, okay, we replace K with its numerical value, then you're looking at 1 times 10 to the third power meter. And so this is basically equivalent to 1,000, or 1 times 10 to the third power. So 1 kilometer is equivalent to 1,000 meters. Okay, let's look at another example here. Convert 3 megaliters to liter, and also 100 milliliters to liter. So if you look at the first one here, 3 megaliters, you know that mega, the prefix mega, is equivalent to 10 to the 6th power. And 10 to the 6th power is basically 1 million. And so that means that you're multiplying this liter by 1 million. And so if you have 3, so we're going to substitute this for the symbol mega. Then we get 3 times 10 to the 6th power liters. Okay, so what about this second one right here, 100 milliliters to liters? So you can see that the prefix that we have here is milli, right? And when you look at the metric system, milli is equivalent to 10 to the negative 3rd power. So it's a negative exponent. So milli is times 10 to the negative 3. And if you remember, a multiplier with a negative exponent indicates that that number is going to be less than 1. And so, for example, 10 to the negative 3 is equivalent to 0.001. And so, essentially, you're multiplying that liter by 0.001, or times 10 to the negative 3. And so, if you replace or substitute m, milli, for 10 to the negative 3, then we have this number here, 100 times 10 to the negative 3rd power liter. But this is not considered proper scientific notation, because if you remember, the correct way to write scientific notation is you have a single digit followed by a decimal point and then other digits that are significant digits. Okay, and so with this, you can plug it into the calculator if you want, 100 times 10 to the negative 3, and you get 0.1 liter. Or you can also use your knowledge regarding moving that decimal place to the left or to the right, depending on whether that number is going to be a number less than 1 or a number greater than 1. Okay, and so if you're multiplying 100 by 10 to the negative 3, that means you're multiplying that 100 by some number less than 1, some fraction. And so you can see that that number 100 will be less once you multiply that by some fraction, some decimal number, right? And so you're going to move that decimal point from right to left because you have that negative exponent. And so we get 0.1 once you move that decimal point 3 places to the left. So that's one way to convert from any prefix to the main unit and vice versa using the metric system. There's actually a shortcut. All you have to do is move that decimal point from left to right or from right to left, depending on if you're converting from a large prefix to a smaller prefix and vice versa. So let's look at this first one again using the second method that I'm going to show you. Convert 3 megaliters to liters. So the first thing that you want to do here is to look at the location of the prefix mega. Where is mega in this metric system? All right, and so mega is right here on the left outside of this blue box here. And we're moving from mega to the main unit, liter, right? From megaliter to liter. And so you're going to count how many spaces it took you to get from mega to the main unit. So from here, you can see that mega is right here. And because it's outside the box, once you move in from outside to inside the box, that's 3 spaces. Okay, because this is 10 to the 6th power, this is 10 to the 3rd power. So this is 3, and then once you get inside, it increases by 1. Okay, so 3, 4, 5, and 6. So you basically moved 6 spaces to the right in that direction, right? From left to right. And so what you're going to do is you're going to move the decimal point from left to right 6 places. Okay, so here we have 3 at the bottom. We have 3 megaliters, right? And then there's a decimal point right here, and we're going to move this 6 places to the right in the same direction as you went whenever moving from mega to the main unit. And so all you have to do now is add 3 zeros here per move. So this is more of a shortcut. So we're going to put a total of 6 zeros because you moved 6 places from left to right. And so the answer here is 3 million liters, or 3 times 10 to the 6 liters. So I think that's a lot easier compared to substituting numerical value for the prefix. All right, so let's look at the second problem here, 100 milliliter to liter. How would you convert this from milli to liter? So again, we're going to locate where milli is. So milli is right over here. And we're going to move this from here all the way to the main unit, which is the liter. So how many times would it take us? How many steps, right, would it take to get from milli to main unit? So that's a total of 1, 2, and 3. So 3 places to the left. So that means you're going to be moving that decimal point from right to left 3 places. So we have 100 and you have the decimal point here, and we're going to move this 3 places to the left in that direction. And so we have 0.1 liter, which is the same as the one we got in the previous slide. So now let's look at the second one here, converting from one prefix to any other prefix and vice versa. So how do we convert from one prefix to any other prefix? You can actually use that second method that I just showed you previously, where you just move that decimal point left to right or from right to left. And so let's look at this example here. Convert 1,000 kilometer to millimeter, and also convert 86 microsecond to gigasecond. All right, so let's look at this first one, 1,000 kilometer to millimeter. So the first thing you want to do again is locate where the prefixes are in this chart. So kilo is right over here on the left, and then millimeter is right here at the other end of the blue box. Okay, so we're moving from left to right. So how many steps, how many places would it take us to get from kilo to milli? So from here we have 1, 2, 3, 4, 5, 6. So remember that if you're inside this blue box, the increment is 1, right? It's a single step each time. But once you get outside the box, it increases by 3. All right, so 1, 2, 3, 4, 5, 6. So that means that we're going to move that decimal point 6 places in this direction, in that direction, to the right. Okay, so we have 1,000. We're going to move that decimal point 6 places to the right. So that's 3 and 6. And then just add 3 zeros per move here. All right, so we have a total of 1 billion millimeters. So 1,000 kilometers is equivalent to 1 billion millimeters. And you can convert this to scientific notation, so you don't have to keep writing the zeros. So it's 1 times 10 raised to the 9th power millimeters. Okay, so make sure you know how to convert from standard notation to scientific notation and vice versa. All right, for the second problem here, we have 86 microseconds to gigasecond. So again, you're going to locate where the prefixes are. So we have micro right over here on the right, outside of the box. And giga is also outside the box here on the left-hand side. I'm sorry, so we have micro on the right-hand side, giga on the left-hand side. All right, so how many steps will it take to get from micro to giga? So we're outside the blue box, so entering the box takes 3 steps. So that's 3, 4, 5, 6, 7, 8, 9, and then it increases by 3, so that's 9 plus 3 is 12, and then another 3, 15. So we're moving the decimal point 15 places to the left. So it's again 3, 4, 5, 6, 7, 8, 9, 12, 15. So that's a total of 15 places to the left. And so here's 86, and we're going to move that decimal point 15 places to the left. So that's 3, 6, 9, 12, 15. And then all you have to do now is add zeros there. All right. So that's the answer. Or you can also convert this to scientific notation, so you don't have to keep writing all the zeros. So that's 8.6 times 10 raised to the negative 14 gigaseconds. So whenever you're converting from one unit to another unit, let's say outside the metric system, it's important to know how to use this method called dimensional analysis. And this is actually the main, the heart of this lecture, how to use dimensional analysis. And dimensional analysis is actually also known as the factor label method. Okay, and this method or technique is used to convert between units, and it uses conversion factors, which are also known as unit factors. So a conversion factor basically gives the numerical relationship between the two units in fraction form. Okay, and so let's say, for example, we have 1,000 gram is equivalent to 1 kilogram. So this is the numerical relationship between the two units. Okay, it's 1,000 gram equals 1 kilogram. And so when you convert this into a fraction form, you can do it in two different ways. The first one looks like this. You have 1,000 gram per 1 kilogram. Okay, and so this is one conversion factor. And the other way to write this is to take the inverse of this. So you would have 1 kilogram in the numerator and then 1,000 grams in the denominator. So this is another conversion factor. So conversion factors, these are basically equivalent to 1, right? When you divide 1,000 gram by 1 kilogram, this is essentially equivalent to 1, because 1,000 grams is equivalent to 1 kilogram, right? They're equal. And so when you divide something by its equivalent, then you get the number 1. So let's look at some examples here regarding conversion factors. Convert the following relationships or equivalents to conversion factors. So the first one here is 1 yard equals 3 feet. So again, whenever you're converting an equivalent, a numerical relationship, all you have to do is turn it into a fraction form. And so you can have two different conversion factors or unit factors. First one would be 1 yard divided by 3 feet. Okay, so that's one conversion factor. And then the second one would be the inverse of this. So instead of 1 yard in the numerator, now you have 3 feet in the numerator and then 1 yard in the denominator. Okay. All right, so B here, we have 1 inch is equivalent to 2.54 centimeters. And so again, you can write down 1 inch in the numerator and then 2.54 centimeter in the denominator, or the inverse, 2.54 per 1 inch. All right, part C here, 1 foot equals 12 inches. So the conversion factor would be 1 foot per 12 inches, or 12 inches per 1 foot. Okay, and the last one is 1 gallon is equivalent to 3.7854 liters. So 1 gallon, so the first conversion factor is 1 gallon per 3.7854 liters, or 3.7854 liters per 1 gallon. how do we actually use conversion factors in dimensional analysis? So let's look at some examples here by converting 99 feet to yards. And we know that 1 yard is equivalent to 3 feet. So whenever you're converting from one unit to another, write down what's given. So that's the very first step. So you're going to write down what's given, which is 99 feet. And then we're going to multiply this value by a conversion factor. Okay? And so a conversion factor here, we have two different conversion factors. The first one is 1 yard per 3 feet, or 3 feet per 1 yard. And so which one would you use in order to get yards in this conversion? Well, we're going from feet to yards, and so the unit that we want is yards, right? And it has to be in the numerator so that the feet can cancel out. And so yard has to be up top in the numerator and feet at the bottom. So always remember, the unit that you want in the end has to be in the numerator. All right, so we're going to go back here and we're going to plug in the conversion factor that's needed. So 99 feet times its conversion factor, which would be in yard per feet. So that's 1 yard per 3 feet. And then now you can see algebraically how the feet, the unit feet cancel out. And what's left is the unit that you want, which is yards. So 99 divided by 3 gives us 33 yards. Okay, or 99 times 1 divided by 3 gives us 33 yards. And so when you look at the given number here, 99, your starting number, contains two significant figures. Okay, so if you started out with two significant figures, your answer should also contain the same number of significant figures. Let's look at another example here by converting 100.0 inches to centimeters. And we know that 1 inch is equivalent to 2.54 centimeters. So the first thing that you want to do here is write down what's given, and we're given 100.0 inches. And you're going to multiply this by a conversion factor so that you get centimeters in the end. And again, there are two different conversion factors, 1 inch per 2.54 centimeters, or 2.54 centimeters per 1 inch. And so we're converting from inches to centimeters, and so we want centimeters in the numerator. So that would be centimeters per inch. And in that case, the conversion factor that we're going to use is 2.54 centimeters per 1 inch. And so we're going to plug that into the conversion factor here. And so now you can see algebraically how the unit inch cancel out, and you're left with the unit that you want in the numerator, which is centimeters. So you can just plug this into the calculator, 100.0 times 2.54 divided by 1, and that gives us 254.0 centimeters. So again, you always have to look at the number of significant figures. If you started out with 4, you should also end up with 4. And here's another example. Convert 150.0 calories to joules. So joule is the unit for energy. And you're going to be learning a lot more about this unit later on in thermochemistry. So 1 calorie is equivalent to 4.184 joules. So in order to convert from calorie to joules, you would need the conversion factor joule per calorie. So that would be 4.184 joules per 1 calorie. So we're going to write down what's given, right? 150.0 calorie, multiply that by its conversion factor, and you get joules, which has a symbol capital J. So again, we're going to plug that in, the conversion factor, 150.0 calorie times its conversion factor, and we get joules. And you can see how the unit calories cancel out, and you're left with the unit in joules. So 150.0 times 4.184 divided by 1 gives us 627.6 joules. Again, we started out with 4 significant digits. We're going to end up with 4 as well. So some conversions require several steps or multiple steps. Sometimes you're not given the exact numerical relationship between the two units, and so you can't convert from one unit to another unit in a single step. It would take you several steps. You would have to break it down into multiple different steps. So for example here, convert 0.0938 inch to meter. So what's given here is 1 inch is equivalent to 2.54 centimeters. So we don't have a direct numerical relationship between inches and meter. And so the first thing you want to do here is to write down what's given. Okay, but the approach here is basically we're going to convert inches to centimeter because that's what we have. That's the numerical relationship we have. And then from centimeter to meter using what you just learned regarding the metric system. Okay, and so we're going to convert from inches to centimeter and then from centimeter to meter using the metric system. So write down what's given, 0.0938 inches or 0.0938 inch times its conversion factor. So again, you want inch at the bottom, you want inch here at the bottom, and the unit that you want up here, because again, we're converting it to centimeters first. So we're going to convert to centimeters, and then we're going to add another conversion factor here. You're going to multiply this by another conversion factor. But for now, you can see how the inches, the unit inch cancels out. And then, so this part right here converts inches to centimeters. And then we're going to add another conversion factor, which allows you to convert from centimeters to meters, or you can just use the knowledge, the thing that you learned regarding metric system. But this is the beauty of using dimensional analysis, because you can add more conversion factors along the way. And so here, now you want centimeter here at the bottom, so that it'll cancel with this centimeter up top. And that would convert it to meters, which is the unit that we want. But what is the numerical relationship between the two units, meter and centimeters? Well, if you look at that chart, right, the metric system chart, centi is a prefix, which is equivalent to 1 times 10 to the negative 2. And so you can just plug that in up here, 1 times 10 to the negative 2, and that's equivalent to 1 centimeter. Okay, so 1 times 10 to the negative 2 meter is equivalent to 1 centimeter. All right, so now you can see how centimeters cancel out, and you're left with the unit that we want in the end, which is meters. So plug that into the calculator. So 0.0938 times 2.54 times 1 times 10 to the negative 2 divided by 1, and we get 0.00238 meters. So we started out with 3 significant figures. Again, we're going to end up with 3 significant figures as well. So this conversion factor right here, you can also rewrite this in a different way. So because this is 1 times 10 to the negative 2, if you don't want to use a negative exponent, you can turn this into a positive exponent, but then you would have to take the inverse of the numbers. So you can also rewrite this in this form, 1 meter equals 100 centimeters. So these two are also equivalent. All right, looking at this second example here, how would you convert 3.50 feet to centimeters? So again, we don't have a direct relationship, or at least we're not given a direct relationship between feet and centimeters. But what we know is 1 inch is equivalent to 2.54 centimeters. If 1 foot is equivalent to 12 inches, then we can convert this, we can convert feet to inches first, and from inches to centimeters. So that would be the approach here. Convert from feet to inches, and then from inches to centimeters. So we're going to write down what's given, 3.50 feet, and we're going to convert this to inches, and so the conversion factor would be from inches to feet, so 12 inches per 1 foot. So we're going to multiply this by the conversion factor, and that cancels the unit feet. And now we've converted it to inches. The next conversion factor converts inches to centimeters. And so we want inches at the bottom and then centimeters up top. Okay, so as you can see here, we have inches at the bottom, centimeters up top, the unit that we want, and inches will cancel each other out because you're basically dividing them. All right, and then plug this into the calculator. So 3.50 times 12 times 2.54 divided by 1, and that gives us 107 centimeters. Again, you look at the number of significant figures here. You started out with 3, you end up with 3. Whenever you're converting between units, there's a lot of times when you will encounter what they call compound units in chemistry and also in physics. A compound unit contains more than one unit or multiple different units. Here are some examples. So you can have grams per milliliter, which is the unit for density. You can have miles per hour, unit for speed, meters per second, also for speed or velocity. Kilograms meters per second squared is the compound unit for force. This is also equivalent to Newton if you've taken physics before. You can also have compound units such as cubic meters or cubic centimeters. All right, so they all contain multiple units. So let's look at an example here on how to convert between compound units. So let's say we have 768 miles per hour and we want to convert this to meters per second, which is also a compound unit. And we have this numerical relationship here between miles and meters and also between hour and seconds. So 1 mile is equivalent to 1,609.3 meters and 1 hour is equivalent to 3,600 seconds. So whenever you're dealing with compound units or whenever you're converting between compound units, you want to convert one unit at a time. So we're going to write down what's given, 768 miles per hour, and we're going to use the numerical relationship or conversion factor between miles and meters. Okay, or if you want, you can start with hours and seconds. But for now, for this example, I'm going to use miles and meters. So I want miles at the bottom and meters up top for my conversion factor. All right, so you can see how the units cancel out. The miles will cancel out. And that takes care of meters because what we want is meters per second. So now we got to take care of hour, and we're going to use this conversion factor here, or this numerical relationship here, and turn it into conversion factor. So we want hour in the numerator this time, and then seconds in the denominator. All right, so that would be 1 hour per 3,600 seconds. All right, and you can see how the hour here will cancel with this hour. Now all you have to do is plug it into the calculators. So 768 times 1,609.3 times 1 divided by 3,600, and this gives us 343 meters per second. And again, we have three significant figures. Our starting number has 3 sig figs. You end up with 3 sig figs as well. And this speed is basically the speed of sound, 343 meters per second. And here's another example involving compound units. So we have to convert 0.750 gram per day to milligrams per hour. And as you notice here, you're not given the numerical relationship. And so sometimes you just have to look it up yourself or just have to remember it. All right, so we're going to start with what's given. So 0.750 gram per day. We know that there's 24 hours in a single day and 1,000 milligrams in 1 gram. And so we can take care of the unit gram first or the unit day. But in this case, we'll take care of day first. So we want day in the numerator and then hour at the bottom. Okay, so you can see how the unit day here will cancel out. So that takes care of the hour. And now we're going to take care of the grams. We can use 1 gram equals 1,000 milligrams, or 1 times 10 to the negative 3. Gram is equivalent to 1 milligram. Again, that milli is equivalent to 10 to the negative 3. And so grams would cancel out, and you're left with the unit that we want, which is milligrams. So now all you have to do is plug it into the calculator. And so 0.750 times 1 divided by 24 divided by 1 times 10 to the negative 3. And that gives us 31.3 milligrams per hour. And as I mentioned earlier, you can also use this conversion factor here. 1,000 milligram equals 1 gram. And we started out with 3 significant figures, so we're going to end up with 3 significant figures. And sometimes you'll also encounter converting between cubic units. And cubic units basically units that are cubed, meaning they're raised to the third power. So for example, cubic centimeters, cubic meters, cubic inches. Let's look at an example here. Convert 1 cubic meter to cubic centimeters. And we know that 1 meter is equivalent to 100 centimeters. And so, again, the very first step here is to write down what's given. So our starting point is 1 cubic meter. And then we're going to multiply this by the conversion factor. We know that conversion factor is 1 meter equals 100 centimeters. But when you look at the units, you can see that this is cubed. And so we would have to cube this as well. And in order to do that, if we're going to raise this to the third power, we would have to do the same thing up top. So raise this to the third power as well. All right, so now you can plug this into the calculator and you get 1 million cubic centimeters. All right, so if you're cubing what's inside, all right, you're cubing everything that's inside, so including the units. So now you get, for example, this numerator here, cubic centimeters, and then here 100 raised to the third power. Okay, same thing down here at the bottom, cubic meters, and 1 raised to the third power. So when you look at this, you can rewrite this in the form of a simpler form right here. So again, we're raising 100 to the third power, not just the units, but also the numbers. And so when you plug this into the calculator, 1 times this number right here divided by 1, we get 1 million. All right, and here's another example. Convert 100.0 cubic centimeters to cubic inches. And we know that 1 inch is equivalent to 2.54 centimeters. Again, we're going to write down what's given, 100.0 cubic centimeters, and we're going to multiply this by the conversion factor. Okay, so we want centimeters up, centimeter at the bottom, inch up top. And so we're going to cube this numerator and also the denominator. And so because we're cubing everything that's inside, you're also cubing the 2.54. So that would be 2.54 raised to the third power. And this gives us 6.102 cubic inches. Or you can rewrite it in this format. And that will give you the same value, 6.102 cubic inches. So again, as you can see, we started out with 4 significant figures. You're going to end up with 4 as well. Here in chemistry, you're also going to encounter conversion with volume units. So for example, 1 cubic centimeter is actually equivalent to 1 milliliter, and 1 cubic meter is equivalent to 1 liter. So how do we convert 15.3 cubic centimeters to liter? All right, so this is going to involve several multiple steps, right? Because we don't have a direct numerical relationship between cubic centimeters and liters. And so what we're going to do here, our approach, is going to be to convert cubic centimeters to milliliters first, and then from milliliters to liters. All right, so we're going to write down what's given. So we have 15.3 cubic centimeters. And then you can see from the numerical relationship here that this is a 1-to-1 ratio. Right, so if we have 1 cubic centimeter, we have 1 milliliter. And so in that case, if we have 15.3 cubic centimeters, we have 15.3 milliliters. But if you want to show this in terms of dimensional analysis, we can do that as well. So this is the conversion factor. You can see how the cubic centimeters will cancel out. And then we're going to convert milliliters to liters. So again, 1,000 milliliters is equivalent to 1 liter. So this is the conversion factor, and milliliters will cancel out. And now we have 15.3 times 1 divided by 1,000. And that basically gives us 0.0153 liter. And here's another example. Convert 125 milliliters per hour to liters per day. Again, we're not given the numerical relationship here, so you just have to remember that there's 24 hours per day, and then there's 1,000 milliliters per liter. So we're going to write down what's given here. 125 milliliters per hour, and we can convert liters to milliliters first, or milliliters to liters. So that's 1,000 milliliters in 1 liter. So the milliliters will cancel out. So that takes care of liters. And then now use the conversion 24 hours per 1 day. And hours will cancel out. And we get 3.00 liter per day. So 125 times 1 times 24 divided by 1,000. And we get 3.00 liters per day. 3 significant figures. We end up with 3 significant figures as well. And the last example here, convert 25 kilometers per liter to miles per gallon. So 1 mile is equivalent to 1.609 kilometers, and 1 gallon is equivalent to 3.785 liters. So again, the very first step here is to write down what's given, 25 kilometers per liter, and we can try to convert miles or kilometers to miles first, which in this case we would use the conversion factor 1 mile per 1.609 kilometer. And so you can see how the kilometers will cancel out here. And that takes care of miles. And now we're going to convert liters to gallons. And so we're going to use the conversion factor 3.785 liter per 1 gallon. All right, and you can see how liters would cancel out. There's liter here and here. And so multiply 25 by 1 times 3.785 divided by 1.609. And that gives us 59 miles per gallon. We started out with 2 sig figs, end up with 2 sig figs as well. Density is a physical property, which means that you can determine the density of any substance without destroying the substance. And the unit that we use for density is usually in grams per milliliter. And so because it contains multiple different units, that's a compound unit. Okay? And density is the mass of a substance per unit volume. So you can determine the density just by weighing the sample and knowing its volume. And so density is a physical property. And you can calculate this by dividing mass of the object by the volume of the object. So D is equal to mass divided by volume. So the symbol for density is D, symbol for mass is M, and symbol for volume is capital V. And here's some examples. of different densities of common materials that you normally encounter in the lab, and they are reported in grams per cubic centimeters. And as you remember, 1 cubic centimeter is equivalent to 1 milliliter. And so this is basically equivalent to gram per milliliter. Aluminum, for example, has density of 2.70 grams per milliliter. Titanium is a more dense metal. And look at gold. Gold has a density of 19.31 grams per milliliter, or grams per cubic centimeters, and it's a lot more dense compared to the first three metals shown here. Water is slightly more dense compared to ice, and that's why ice floats in water. Air has a density of 0.0012 gram per milliliter, whereas helium is 0.00018 gram per mil. That's why helium floats in air. All right, so you just have to remember that substances with lower density will float on those with higher density. So how do we determine the density of an object experimentally? So it's different per physical state, right? So if you have a liquid, you would determine the density of the liquid differently compared to solid or a gas. For liquids, all you have to do is take the mass of the liquid by weighing it using a balance with known volume, and then solve for density using that equation that we just looked at earlier. And so here's an example. If the mass of 10 milliliter liquid is 10 grams, what is its density? Well, you know the mass of that liquid, you know the volume of that liquid that you weighed. All you have to do is plug it into the equation. D equals m divided by v. Mass is 10.0 divided by volume, which is also 10.0. And that gives us 1.00 gram per mil. So you can see that gram is a unit of mass, milliliter is a unit of volume, and so they won't cancel each other out. You see that you started out with 3 sig figs, you divided that by 3 significant figure, and so make sure you remember the rule when it comes to multiplication and division, right? So your final answer will contain the same number of sig figs as the one with the lower number of sig figs. So since they both have 3 significant figures, your calculated answer will also have 3 significant figures. For solids, it's a little bit different. When you take the mass, so all you have to do is take the mass of the solid object by weighing it using a digital balance, and then you determine its volume either directly or indirectly. So taking the mass of the solid is pretty simple, but when it comes to volume, you can do it 2 different ways. One is using a direct method, and the other one is indirect method. So a direct method is used for objects with regular shape. Okay, so you can use equations for volume. Like for example, if you have a rectangular object, then you can use the equation for volume: length times width times height. So this only works for objects with regular shape. But what if you have irregular shaped objects? Well, you have to use an indirect method, and usually it's water displacement. Okay, and so what you can do is you can use a graduated cylinder or whatever volumetric glassware that you can use, and you want to take note the initial volume of the water. Okay, and so then you have a solid object with irregular shape, and you're going to put this inside the graduated cylinder, and then the water rises, or the liquid level rises. And so when this liquid level rises, you're going to take the difference between the final volume, okay, the final volume and the initial volume, right? So this change here in volume is the volume of the liquid because again, solids take up space. And what that means is space in terms of volume. And so the volume of the solid then is equivalent to V2 minus V1, or meaning the final volume minus the initial volume. So let's look at an example here on how to determine the density. First, let's look at solids. A solid object has a mass of 40.0 grams. What is its density if the initial volume is 30.0 milliliter and the final volume is 40.0 milliliter? And so whenever you're dealing with word problems, you want to write down what's given, right? So the mass of the object is 40.0 gram. And the volume, so we have initial volume and final volume. The final volume is usually larger than the initial volume. So we have V2 is 40 milliliters and V1 would be 30 milliliters. And so the difference here is 10 milliliters. Okay, so we're going to divide 40 by 10 milliliters and we end up with 4.00 grams per milliliter. Again, we started out with 3 significant figures here for mass and also 3 significant figures for volume, and so your density should also contain 3 significant digits. So how do we solve for the other variables in that formula for density? Mass and volume, right? So density is equivalent to mass divided by volume. If you were given, let's say, the density and volume, how do you solve for mass? Or how do you solve for volume if you were given density and mass? So again, if algebra is not your forte, then this is going to be very helpful. But if you think your algebra is pretty strong, then this is going to be really basic for you. All right, so let's look at how to solve for mass. Again, so let's say you're given the density value and the volume. How do you solve for mass? So we know that density is equivalent to mass divided by volume. And so what you want to do here is to isolate mass by itself, right? You want to isolate m by itself. And so how do we do that? Well, all you have to do is move that v, that volume, to the left-hand side of the equal sign. And in order to do that, you multiply both sides by volume. And so when you look at the right-hand side of the equal sign, you can see that the volumes would cancel each other out. And so if you clean this up a little bit, it looks something like this. All right, so mass is equivalent to density times the volume. For volume, it requires a little bit more, an extra step. So again, we start out with this formula for density. So density is equivalent to mass divided by volume. And we want to isolate volume by itself. And so we're going to move v to the left-hand side of the equal sign. Okay, so we're getting rid of the fraction basically. And so we're going to multiply both sides by v, just like what we did for mass. And so you can see that volume would cancel each other out. And if we clean this up, we have this equation, v times d equals m, which is the mass. And so now we can easily isolate v by itself by simply dividing both sides by density, right? Because we're trying to get rid of that d density on the left-hand side. So we're going to divide both sides by d, and these will cancel out on the left-hand side of the equal sign. And we can clean this up, and we get the formula for volume. So volume is equivalent to mass divided by density. All right, so let's look at an example here for mass. Okay, let's say iron. Iron has a density of 7.87 grams per cubic centimeters. If its volume was 8.83 cubic centimeters, what is its mass? All right, so we already solved the formula for mass. All you have to do now is plug and chug, right? Plug in the numbers. And so we know the density, we know the volume, we can solve for mass. So mass is equivalent to mass is equivalent to density times the volume. So the density is 7.87 and the mass is 8.83 cubic centimeters. So here you can see that the unit cubic centimeter will cancel each other out right here. So in that case, 7.87 times 8.83 gives us 69.5 grams. So again, you have 3 sig figs here, 3 sig figs for volume. So your final answer should also have 3 significant figures. Okay, so you go with the number with the less number of significant figures. All right, let's look at another example here involving volume. Mercury has a density of 13.534 grams per milliliter. What is the volume of a 1,213 grams of mercury? All right, so again, we have the formula for volume here. So all you have to do now is plug and chug. But you always want to make sure that the units actually match up. Okay, otherwise the equation will not work. So if one unit doesn't match the other unit, then you convert it to the correct unit first. All right, so write down what's given. We have density and we have mass. And all you have to do now is plug in the numbers. So, well, let's double check if the units match, right? So we have grams per milliliter for density. For mass, we're given grams. So if you were given, let's say, kilograms instead, or maybe pounds, then you would have to convert that unit to grams first. But since we already have grams, we can easily just plug in the numbers. So we have 1,213 grams divided by 13.534 grams per milliliter, and you can see how the units cancel each other out. And what's left is the unit for volume. So 1,213 divided by 13.534, we get 89.63 milliliters. So you can see that we started out with 5 significant figures for density and 4 significant figures for mass. So your final answer should have the same number of sig figs as the one with less number of sig figs. So this is the last topic that I want to cover, temperature measurements. So there are 3 units of temperature that are often used in the STEM field. There's the Fahrenheit, Celsius, and Kelvin. And Kelvin is known as the absolute temperature. And so 0 Kelvin is basically the lowest temperature possible. And they call that the absolute zero, right? 0 Kelvin is absolute zero, and Kelvin is the absolute temperature. And make sure you know how to convert between these 3 units. So when you're converting from, let's say, degrees Celsius to degrees Fahrenheit, you use this equation given here. So let's say you have 0 degrees Celsius. So all you have to do is plug in 0 here into this equation, and you get degrees Fahrenheit. And if you're converting from degrees Fahrenheit to degrees Celsius, you would use this equation here. So all we did is really rearrange this equation for Fahrenheit and isolated degrees Celsius. So we subtracted 32 on both sides and divided by 1.8 on both sides, and we end up with this equation for degrees Celsius. So it's degrees Fahrenheit, whatever the number is, minus 32 divided by 1.8. And lastly, kelvins. How do we convert from, let's say, degrees Celsius to Kelvin? All you have to do here is to add 273.15 to the degrees Celsius. So let's say we have 100 degrees Celsius. How do you convert that to Kelvin? All you have to do is add 273 to that number. So 100 plus this number, you get 373.15. Sometimes you'd be given the temperature in Fahrenheit, and then you would have to convert that to, let's say, kelvins. So the approach there would be to convert Fahrenheit to degrees Celsius, and from degrees Celsius to kelvins. All right, so let's look at an example here, a simple example. Water freezes at 0 degrees Celsius. convert this to degrees Fahrenheit and kelvins. So to convert this to degrees Fahrenheit, we use this equation up here. So all you have to do is plug in 0 for degrees Celsius. Okay, multiply that by 1.8, which is basically 0, and then add 32, and we get 32 degrees Fahrenheit. All right, and then in order to convert this to Kelvin, all you have to do is add 273.15 to degrees Celsius. And so since we have 0, we get 273.15 Kelvin.